Hi, this is Melody Rondeau, and we're going to be talking about key features of quadratics. Our essential question: how do we find the key features of a quadratic and use them to graph? And then our learning targets: I can identify the intercepts of a quadratic function, and I can interpret the key features of a quadratic function graph in context. And specifically, the key features we're looking at there are zeros, maxima, and minima, and symmetry of the graph. And so that second learning target, we will not fully finish today. We're just going to start with what are those key features, and then we'll apply them to a context in the next lesson. So here we go, getting started. Key features of a quadratic. Right here, I'm going to need you to pause the video and go ahead and make as good of a copy of this graph as you can. Note those points that are on the graph, those gray points. We're going to need those to be as accurate as possible because we're going to be talking about what those points are in reference to the graph. So again, pause the video for a second and make a nice pretty copy of the graph. Okay, so now that you've made a copy of the graph, let's go ahead and label these different features of our graph. The first one we have is right here at the bottom. We have seen this one before. It's called the vertex, and it is represented, or the letters that we use to represent it are H and K. In this context, that would be 1, -4. There's our H and K. And it also tells us it is either the max or the minimum, the maximum or minimum, depending on the shape of our graph, whether our graph opens up or opens down. So this one is the minimum because it's the lowest. Remember, on the ends of our graph, there would be arrows up here going forever and ever. So it is the lowest point. So this one has a minimum. Minimums go with graphs that open up, and maximums go with graphs that open down. And we have gone over that before, but that's just a quick reminder. Cool. And then we also have our axis of symmetry that we talked about in our last lesson on graphing. That that axis of symmetry, all the points on one side match all the points on the other. It's kind of like a mirror image. And so there's the axis of symmetry that we are going to label with sorry, I'm thinking about where I want this to go. Right here, that is x equals h. So we steal that h value from the vertex, and this again is called the axis of symmetry. All right, and then the other points that we have on the graph, these are not new, but might be the first time that we specifically have talked about them. So these 2 points right here, these two are called the zeros or the roots or the x-intercepts. So all three of those terms are what we use to name those particular points. Again, zeros or roots or x-intercepts, and we use them somewhat interchangeably right now. So you need all three vocabulary terms there. Then one other thing I want to add here to find, so a little comment here, to find these, whether you call them zeros or roots or x-intercepts, we are going to set y equal to 0. So that's how we find them if we have an equation. So here we're looking at the graph, and it should be very easy to find them. It's those points where we cross the x-axis. Sorry, I forgot what I was writing here. To find these, we're going to set y equal to 0. Okay, so the last point we have here, this one right here, is called the y-intercept. And this one's a little more boring. It only has one name, the y-intercept. And it is the place where our graph crosses the y-axis. So intercept is where we cross. So right there is the y-intercept. And so that one, if we have an equation, I'm going to make a note here to find this. We're going to set x equal to 0. And we're going to practice that so you guys will have a chance to see it in just a minute. Other things for these really quickly too is x-intercepts. In this case, I'm going to go ahead and name them. They would be -1, 0. Notice the y value is 0, the x value is the intercept. And this one would be 3, 0. So there you go, -1, 0, and 3, 0. And typically a quadratic has 2, but every once in a long while it has 1 or none. But typically it does have 2. So there you go. For the y-intercept on this one, it would be the ordered pair 0, -3. And hopefully you can see there that the x value is 0. Awesome. Okay. And I think that's it. Those are our key features, and we're going to get started with some examples. So here we go. Find the x and y intercepts of the quadratic, then sketch the graph. So to find the x intercepts, we're going to make the y 0. So I'm going to say y equals x squared minus 4x plus 3. To solve this, we're going to use our factoring that we've been practicing. And so here we go with factoring. I'm going to double check. First step, is there a greatest common factor? No, there is not. Then I'm going to do, since I have 3 terms, I can't split it into 2 groups. So I'm going to do the x, and I'm going to multiply the number in front, which is a 1, and the number in back, which is a 3. So 1 times 3 is going to give me 3, and don't forget your x squared. So I'm multiplying to make 3x squared, and I'm adding to make -4. So multiply and add. And the numbers that are going to do that for me are going to be -1x and -1x and -3x. And if you remember how to do the shortcut, actually this time I'm going to show us that shortcut. If you don't remember how to do the shortcut, you could split your middle term into 2 using your special numbers and factor by grouping. Go back and look at a previous set of lessons if you don't remember how to do that. Otherwise, the way I'm going to show you is doing the shortcut. Since we have that nice fabulous 1 in front, we are able to go straight to an answer of parentheses here, and I use my variable and put it in the front, and then those special numbers, I'm just going to take the number part and fill them in my parenthesis. So -1 and -3. At that point, we're ready to go ahead and solve. Since it equals 0, we take each parenthesis and set it equal to 0. Then I'm going to solve. So add 1 to both sides, I get x equals 1. And on this one, add 3 to both sides, and I get x equals 3. So those would be my x-intercepts, and I'm going to use those to help me graph in just a second. But first, we still have to find the y-intercept. To do that one, we are going to make the x equals 0. So this part is down here is going to be finding the y-intercept. So I'm going to say y equals, and I'm replacing all the x's with 0. So here we go. So I put those in, and now I'm going to simplify. And this is the nice one. Y-intercepts are super quick and easy. 0 squared is 0. -4 times 0 is 0. So I have another 0. So -0, and then plus 3. So yeah, just the 3 there. Super convenient. So now I can use those values on my graph, and this is just a sketch. So we're just going to do our best to estimate a parabola. So I'm going to put these points on the graph, 1, 2, 3. For my x, I have a point at 1 and a point at 3. And then for my y, 1, 2, 3, and a point at 3. All right, and the other thing for when I sketch this is that I need to know what direction it goes. You can kind of see the shape, but double check that number in front. We learned about the a value, so in this case, a is 1. the number in front of x squared. Since it's positive, a positive 1, this means it's going to open, that this opens up. So I'm going to sketch my graph going through the points. Somewhere down here it turns and opens up. And again, we're just sketching, so it doesn't have to be perfect, but make sure it goes through the points. So there's our first one. On to the next one. Same directions. So we're going to start by finding the x and y intercepts. To find the x-intercept, I make the y 0. And I'm going to look for, I'm going to use factoring to help me solve this. So I'm going to look for the greatest common factor. And on this one, since I have a negative in front, I'm going to take, there isn't really a common factor, but since the negative is in front of x squared, my life will be much easier if I factor it out. So I'm going to actually say yes, and I'm going to say it's negative 1. So I'm going to factor out negative 1 and put it in front of parentheses. And then I have x squared plus 2x and minus 8. Then once again, I am looking to factor. I have 3 terms. I can't split it into 2 groups, so I'm going to do the x. And on this one, I might just sneak it on the side here because I kind of don't have a lot of room. So remember, the 2x would be in the bottom, that middle term, and then I take the number in front of x squared and the number in back, and I'm going to multiply them for that top number. So 1 times negative 8 is negative 8. Multiplying to make negative 8, x squared, adding to make 2x. The numbers that are going to do that, let's see, looks like 4x and negative 2x. Double check it. 4 times negative 2 is negative 8, and 4 minus 2 is 2. All right, once again, since I have that 1 in front, I can go straight to parentheses and say x plus 4 and x minus 2. Remember, I stole those from the numbers in my x. All right, so I'm setting each part equal to 0. I have x plus 4 equals 0 and x minus 2 equals 0. And I'm so sorry for that little control thing. I'm not exactly sure why that's there. Okay, so then I'm going to subtract 4 from both sides. I get x equals negative 4. Add 2 to both sides, and x equals 2. The last thing I need is the y-intercept. So that's going to come from plugging in 0 for x. So I'm going to make all my x's 0. So careful, the negative is not part of the x. It's in front of the x, negative 1 in front. And then it was x squared, so I have 0 squared, minus 2 times 0 plus 8. However, even though I made a big deal about that negative in front of the 0 squared is 0 times anything is going to be 0. So this is just going to be one big fat y equals 0 minus 0 plus 8. So I have y equals 8. Then I can go to my graph and plot those points. So I have negative 4, 1, 2, 3, 4. There's one of my x-intercepts. And then I have 1, 2. And then I need y at 8. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, way up there. And I'm going to put a point. And again, I'm going to connect the dots. I'm going to double check the number in front of my x squared. In this case, it is that negative 1. So a equals negative 1, which means my parabola opens down. Okay, so then I'm going to connect the dots and have my parabola open down. This point is not the vertex, so be careful. The vertex is somewhere in there, but that's not actually the vertex. So this is going to open down. I'm going to come up like this, something like that. And again, it's a sketch, so it doesn't have to be perfect. Uh-oh. Okay, so let me try that one more time. Connect that through nice and smooth, curve as best I can. There we go. So that finishes our second example. Okay, so here we are on example 3. This one, our directions have changed a little bit. We have find the vertex and y-intercept of the quadratic, then sketch the graph. All right, so whoopsie. Let's go forward. There we go. So the vertex, remember, comes from h and k. And so my vertex here would be negative 3 and 1. Reminder, that's because h does the opposite. So even though it says plus, the h value is actually the opposite. It's going to be a minus. So that's a little bit weird. Remember, we talked about h does the opposite of what it appears. All right, so our vertex is at -3, 1. We're also supposed to find the y-intercept. So a reminder, if we're finding the y-intercept, we're going to plug in 0 for x. So don't mind that background noise. Here we go. And so I have negative, then parentheses, 0 for x, plus 3 squared plus 1. So this one is going to be a little different. Our 0 isn't going to affect our problem as much. So 0 plus 3, order of operations, parentheses first. 0 plus 3 is 3. And then after parentheses, I'm going to do exponent. So I'm going to do 3 squared, not the negative. This is a -1 in front. That's multiplication. Well, -1 times 3. We can't do that until we do the exponent. So -1, 3 squared is 9, and then plus 1. So I get -9 plus 1, because -1 times 9 is -9. And then finally, y equals -8. All right, so with that information, we're going to sketch the graph. So on my graph, I'm going to go -1, 2, 3, and then I'm going to go up 1 for my vertex. And then I have a y-intercept at -8. So 1, 2, 3, 4, 5, 6, 7, 8, right there. I'm going to double check the number in front because that's my a value. So a is -1, which means this opens down. All right, so I'm going to connect the dots here, opening down. I'm going to try that one more time. There we go. All right, so we are going to open down. I'm just going to go a little bit. I'm going to do this side first, I think. Ooh, opens down like that, and then like that, something like that. Remember, it's just a sketch. It doesn't have to be perfect. Okay, for this last one, our last example, we're going to use the same directions, find the vertex and y-intercept of the quadratic, then sketch the graph. Okay, so here we go. I am going to find the vertex. So my vertex again is h and k. So h and k. H is going to do the opposite of what it appears. So even though it looks like -4, it will be a +4. And then k is 2. And then I need my y-intercept, which I'm going to find by plugging in 0 for x. All right, so when I do that, I get 0 minus 4 is -4. And then I square it, so I get 16. -4 times -4 is a positive, 16. And then 16 plus 2 is going to give me 18. Awesome. All right, so on this one, I'm going to go over for my vertex at 1, 2, 3, 4, and up 2. Now, this one, I'm going to do something funky and scale my graph. I'm going to say every mark I make on the y-axis is going to be 2. So I'm going over 4. So I'm going to 1, 2, 3, 4, and I'm going to go up 2, which is only a 1. I know that's weird, but I have to get all the way up to y equals 18. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, like so. So I'm kind of cheating how I scaled my graph. And then I'm going to double check the number in front is a 1. So that means a equals 1. And my parabola opens up. And so with that, I'm going to sketch the graph. So I'm going to go this way, like so. And I'm going to kind of match. Remember, we have that fabulous axis of symmetry that goes right through our vertex. So I'm going to basically try to make this side kind of match that. Remember, it is still just a sketch, so just your best effort. And that finishes our notes. Make sure to check Google Classroom. And thanks. Goodbye.